China's massive thorium bet, try typing top 10 countries leading in nuclear technology into Google or YouTube. You'll see the US, France, Russia, Japan, and of course, China. But if you search for top countries developing thorium, you'll notice something strange. Most of the West is sitting this one out. Thorium. It's an element you almost never hear about in Western news. It's not on any strategic list from the US Department of Energy. And it's not because it's ineffective, but because it's just so different. Unlike uranium, thorium isn't easily used for nuclear weapons. It doesn't produce plutonium. It doesn't cause Chernobyl-style meltdowns. And most importantly, it's 3 to 4 times more abundant than uranium, much cheaper, and can operate in nuclear reactors that don't need water for cooling, a crucial advantage in the era of climate change. While the West chose uranium, a dangerous, expensive, and difficult to handle fuel, China has quietly taken a different path. They're investing billions of dollars into an element the rest of the world sees as unsexy, hoarding thorium from rare earth mines, and developing a nuclear reactor that produces almost no radioactive waste, needs no water for cooling, and has zero meltdown risk. They're not just researching. They've been quietly accumulating thorium for decades, as if knowing that one day this element would become the clean oil of the 21st century. From rare earth mines in Inner Mongolia to research institutes in Shanghai and Wuhan, a thorium ecosystem is forming, with the potential to power an entire nation for 20,000 years, while generating almost no nuclear waste. And if you haven't heard much about this, maybe it's because China doesn't want you to know. Or worse, because the West is sitting out a revolution they once pioneered. So what exactly is thorium? Why is China investing in it? And what does that mean for the future of energy and the geopolitical future of the entire world? Join Top 10 Discoveries Official as we uncover Beijing's ace in the hole. Thorium, a name that sounds alien in the modern nuclear energy dictionary, is actually a familiar element that once had a chance to reshape the entire global nuclear industry. But in a controversial historical twist, the West, especially the US, said no to it. And now China is exploiting what Washington once deemed unnecessary. Thorium chemical symbol, Th232, is a weakly radioactive metallic element, naturally occurring in the Earth's crust 3 to 4 times more abundantly than uranium. Under ideal conditions, thorium doesn't require complex enrichment like uranium-235 and can operate safely in molten salt reactors, a type of Generation 4 nuclear technology with the potential to operate at high temperatures without pressure, almost eliminating the risk of core meltdown or explosion. Unlike uranium, thorium does not spontaneously fission, but when activated in a reactor, it transforms into uranium-233, an extremely efficient fissile fuel, releasing more energy than conventional uranium-235. In theory, just 1 ton of thorium could fuel an entire small city for more than a year. Some scientists even estimate that, with current global reserves, thorium could power all of humanity for 20,000 years, emitting no CO2, requiring no high pressure, and producing almost no long-lived nuclear waste. So why did the US reject it? It wasn't a decision based on engineering, but on politics. In the 1960s, at the Oak Ridge National Laboratory, USA, scientists successfully developed a thorium-fueled molten salt reactor. The experiment succeeded. Everything was feasible. But then, the program was canceled. The reason? Uranium is easy to produce plutonium, the raw material for nuclear bombs. Thorium is not. It cannot create effective nuclear weapons. During the Cold War, when the US and the Soviet Union were in an arms race, that made thorium a non-military element and not favored. So because of strategic circumstances, the US turned one of the safest elements into something to be discarded. When the West turned its back, China began to study, quietly, persistently, and now they have put into operation the world's first molten salt thorium reactor, a technological feat that no Western country has currently achieved at the level of commercial experimentation. They don't need to enrich uranium. No high pressure is required. It doesn't create plutonium for bombs, but is enough to provide clean energy to remote areas like the Gobi Desert, or even to mobile military bases in the future. While the US is still arguing about innovation budgets, China has finished building a prototype for the future. Not with plutonium, but with thorium, the element that the US once pioneered and then abandoned. Thorium is not just an element. It's a big question about choices, a test of vision. However, all the technological development efforts are only the first step, because for a true energy revolution to take place, China needs a prerequisite, a large enough source of raw materials to fuel this dream for centuries. And now they may have found it, right beneath their own soil. According to data from the International Atomic Energy Agency, IAEA, China currently holds about 100,000 tons of thorium, which is already one of the largest reserves in the world, second only to India. But a nationwide geological survey conducted by the China Institute of Atomic Mineral Exploration and Remote Sensing, completed at the end of 2024 and published in January 2025 in the Geological Review, has completely changed the game. This report asserts that, if potential resources are fully exploited, China could possess up to 1 million tons of thorium, 10 times the confirmed amount. This potential reserve is mainly concentrated in the Bayan Obo mine in Inner Mongolia, one of the largest rare earth mining centers in the world today. And if that number is accurate, China holds enough energy to power the entire nation for 60,000 years. Based on the current electricity consumption level, approximately 7 trillion kilowatt hours per year. That number seems far-fetched, but it is reinforced by very real data. The waste from an iron mine in Bayan Obo alone over the past 5 years contains enough thorium to power all households in the United States for 1,000 years, based on a national electricity consumption of approximately 4,000 billion kilowatt hours per year. The South China Morning Post described this discovery as an endless source of energy right under our feet, while Money Control called it a silent overthrow of the global energy order. It's not just Bayan Obo. The new survey has identified 233 thorium-rich areas stretching from Xinjiang to Guangdong, many of which were previously overlooked due to a lack of commercial value in the past. Now, these anonymous spots have become the atomic gold mines of the 21st century. To easily visualize, with 1 million tons of thorium, if used in a molten salt reactor with a capacity of 1 gigawatt, consuming about 1 ton of refined thorium each year, China could operate 1,000 reactors simultaneously for 1,000 years. That's not even counting the fact that thorium can be extracted from the waste of the rare earth mining industry, a field in which China currently accounts for 85 to 90% of the global market share. In other words, China can both supply rare earths to the world and recover thorium for nuclear fuel, an unprecedented double cycle. Compared to other countries, India is still recognized as having the largest theoretical reserves, approximately 846,000 to 1,070,000 tons, depending on the source. The United States, Australia, and Brazil each have an estimated over 500,000 tons, but have not been exploited on a large scale. China, with 1 million tons of potential, available rare earth industrial infrastructure, and the capacity to build experimental reactors, is the only country that can turn thorium from theory into reality. Although some Western scientists remain skeptical, arguing that 60,000 years of energy is just a theoretical number, not taking into account population growth and consumption needs, it cannot be denied that no country has ever stood so close to the ultimate clean energy weapon. And if China controls the thorium source and the related technology chain, the world will have to rewrite the entire map of energy geopolitics, in which the leading position is very likely no longer in the West's hands. But there is an important reality that most of the world has not yet paid attention to. Having reserves is not enough. There must also be a strategy to accumulate, process, and protect them. Thorium, although more abundant and less radioactive than uranium, is still a nuclear element, requiring strict control, both in terms of safety, environment, and national strategy. So how will China accumulate this huge amount of thorium? First of all, unlike uranium, thorium does not require enrichment. So the input processing process is simpler. Thorium is separated as a byproduct during rare earth mining, especially from monazite and bastnasite minerals, two types of ore that China currently controls the majority of the global supply chain. In models like Bonobo, thorium is not mined separately but comes with precious metals such as neodymium, dysprosium, which are used for battery, magnet, and military technology. This means China's rare earth production process is also a process of quietly accumulating thorium. Second, China is not in a hurry to sell or process everything. They are building specialized thorium storage facilities, many of which are located near rare earth industrial parks in Inner Mongolia and Sichuan. According to a leaked internal report in 2024 from the Shanghai Institute of Applied Physics, the Chinese government has directed mining companies to classify and store thorium oxide, THO2, separately in solid powder form, preserved in dry and isolated conditions, ready for molten salt reactors in the future. Technically, thorium can exist in the form of the O2 thorium oxide, stable, easy to transport, non-explosive, suitable for long-term storage. Pure metal thorium, rarely used because it is easily oxidized but has a higher energy density. Recent reports show that China is accumulating thousands of tons of THO2 each year, mainly from rare earth industrial waste. This amount is not currently used because there are no suitable commercial reactors. And instead of treating it as waste, Beijing is quietly turning it into atomic gold of the future. Another important strategy is to combine thorium storage with the development of nuclear fuel recycling technology, allowing the recovery of thorium from incomplete reaction processes, reducing waste and the risk of radioactive leaks. This helps China build a closed cycle from rare earth mining, thorium separation, safe storage, to use and recycling, something that very few countries can do on a large scale. And finally, the issue is not how much there is, but who controls the storage and distribution of thorium for the future. Once China establishes an industrial ecosystem around thorium, they will not only have an endless source of fuel, but will also become the country holding the key to next-generation nuclear energy, just like they did with rare earths. If thorium truly becomes a major energy source in the future, the world will witness not just a technological advancement, but a complete restructuring of the global energy, economic, and power ecosystem. China is getting very close to that. But if this happens, what awaits the world on the other side of the thorium revolution? First, the geopolitical energy map will be rewritten. Currently, more than 80% of global energy still comes from fossil fuels, and more than half of the world's countries depend on oil and gas imports. If thorium, with its advantages of abundance, no enrichment required, and low waste, is truly commercialized on a large scale, this could disrupt traditional supply chains. Oil superpowers like Russia, Saudi Arabia, or Iran could lose strategic positions. Conversely, countries with large thorium reserves such as India, 846,000 to 1,070,000 tons, Brazil, more than 500,000 tons, and the United States, more than 500,000 tons, will enter a race to gain completely new energy independence. China, if it successfully exploits the potential amount of thorium up to 1 million tons, will not only have enough electricity for 60,000 years, but could also become an exporter of thorium reactor technology, similar to how it is promoting the Hualong-1 reactor. Developing countries, lacking energy and budgets for uranium, may choose the Chinese model as a less restrictive path in terms of cost and international control. Second, thorium could liberate nuclear energy from the shadow of war. One of the biggest obstacles that makes nuclear energy always closely monitored is its association with weapon manufacturing. But thorium cannot be used directly to make atomic bombs and must go through a complex process to create U-233. This reduces the risk of weapon proliferation, paving the way for nuclear energy to be more widely accepted in developing countries, where technical support has been banned or restricted. The International Energy Agency, IEA, once estimated that if the world achieves net zero by 2050, at least 15% of global electricity will need to come from nuclear energy, double the current amount. If thorium proves effective, it could account for a large proportion of this, thanks to lower costs and higher safety in molten salt reactors. Third, new technology competition and standardization will explode. If China is the first country to successfully operate a commercial thorium reactor, it could establish a global technology standard, similar to how the United States did with the internet, or Japan with high-speed rail technology. This would create a made-in-China ecosystem in the field of Generation 4 nuclear energy, from equipment, materials, to safety procedures. Countries will be forced to buy licenses, depend on Chinese supply chains, or develop their own standards, leading to a huge wave of investment and technology competition. Currently, India is also developing the AHWR 300L EU thorium reactor project, expected to be operational from 2030. The US has startups like Thorium, Flybe Energy pursuing the molten salt reactor model, but the West's delays could cause them to lose their leading position, just like they lost the lithium battery industry to China. Finally, thorium could create a completely new energy market, carbon-free, independent, and almost infinite. A report by the World Nuclear Association estimates that using just 1 ton of thorium in a molten salt reactor could provide enough electricity for 1 million people for a year. If this calculation is correct, the potential is unimaginable. 1 million tons of thorium in China equals electricity for 1 billion people for 1,000 years. And if thorium becomes a global energy source, this will not only affect the fuel market, but will also reshape the financial industry, infrastructure, and international strategic alliances. Throughout the 20th century, global power was tied to oil and uranium. The United States, thanks to owning a global oil network and leading nuclear technology based on uranium, set the rules of the game. But thorium cannot be used for weapons, and that, in a post-Cold War world, is an advantage. An energy source that is not easily weaponized, cleaner, safer, and cheaper will change the entire strategic balance of energy security. China knows that, and Beijing is acting as if they were the first to read the draft of the future. So where does the US stand in this game? Today, as China announces the potential of 1 million tons of thorium, builds experimental reactors, and plans to commercialize molten salt technology in the early 2030s, the US is still struggling at the stage of funding primary research. The only molten salt reactor currently funded by the US, Thorium or TerraPower, has not yet passed the industrial demonstration phase. In a 2024 report by the United States National Security Commission on Strategic Technologies, experts warned China may control Generation 4 nuclear technology before 2035. If this happens, Beijing will not only be self-sufficient in energy, but will also be able to export thorium technology to developing countries, including partners in the BRI, Belt and Road Initiative, from Africa to Southeast Asia. Imagine a future where China supplies thorium reactors, safe, requiring no water cooling, operating in the desert, suitable for resource-scarce countries, would seriously weaken US geopolitical influence, especially in strategically competitive regions such as the Middle East, Africa, and South Asia. If uranium is the foundation of the 20th century nuclear order, thorium is very likely to be the catalyst of the 21st century. An energy source that does not need to be re-enriched, has little radioactive waste, does not create plutonium, and is mainly concentrated in India, China, Australia, Turkey, and the United States. Among them, China is the only country with a comprehensive plan to exploit, store, develop technology, and commercialize from exploitation to reactor operation. If Beijing plays the role of a new OPEC of clean nuclear energy, the world will have to readjust energy alliances from Japan to Europe. Countries that once depended on uranium may have to shift to importing thorium technology, and accordingly, open a new form of dependence, this time on China. So far, the US response remains open. Several startups in the United States, such as Thorium, Flybe Energy, and Copenhagen Atomics, international cooperation, have made efforts to revive thorium technology, but have not received strong support from the government. Meanwhile, the US Congress in 2023 discussed the Thorium Frontier Act to invest in the exploitation and research of molten salt reactors. but the budget was cut in the final stage due to a lack of political priority. Many nuclear energy experts at the Brookings Institution and CFR, Council on Foreign Relations, have warned that the U.S. is losing strategic initiative in the next-generation nuclear game, while China not only builds but also owns the rare earth, thorium factory, and output market supply chain. A wake-up call is being raised, and perhaps if the United States does not want to fall into the situation seen with rare earths or lithium-ion batteries, the thorium race will be the next decisive test. From an element abandoned by the West, thorium is becoming the focus of an energy race, where China is not only leading, but also rewriting the rules of the game. With huge reserves and a technology ecosystem taking shape, Beijing is turning thorium into a strategic card, not only to solve the domestic clean energy problem, but also to reshape the global geopolitical position. In a world that is thirsty for energy and panicking in the face of the climate crisis, the country that owns next-generation nuclear energy, cleaner, cheaper, and non-weaponized, will be able to rise to shape a new energy order. And in that race, China seems to have shortened the distance, not by noise, but by thousands of tons of thorium quietly put into the system. Each reactor laid the foundation. Each nuclear cooperation project with Africa, Southeast Asia, or the Middle East quietly formed. So the question is, will the United States, the country that pioneered thorium technology in the 1960s, accept to step back? Or will it reinvest, reshape its strategy, and return to the game before it's too late? We are witnessing a turning point in the history of global energy. And thorium, the element that has quietly lay in the ground for millions of years, may be what decides who owns the future. What do you think? Is thorium really the miracle fuel, as many people believe? And will China hold the future with that huge fortune? Share your perspective in the comments section, because this is not just China's story, but the future of us all. Don't forget to subscribe to Top 10 Discoveries Official to not miss in-depth analyses of mega projects, breakthrough technologies, and the geopolitical race that is quietly changing the world.